Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to cover the last of the classification approaches that we're going to talk about, and that's natural breaks. And so if we remember back to the first video, we said that natural breaks finds natural places to put class breaks. What I want to do in this video is sort of explain what that means in a little bit more detail and look at conceptually what this looks like. So let's go ahead and give ourselves a little bit of space here. And let's talk about this idea of natural breaks. So what natural breaks aims to do is it aims to set up class breaks in what we would consider to be the best place for them. And typically what the best place means is it means it's going to look for wide gaps in the data set. Right, it finds wide gaps in the data set to use as class breaks. Now, the sort of algorithmic computational part of this is a lot more complicated than I think is relevant here. But we can get an idea conceptually of what natural breaks tries to do by just looking at a histogram and looking for places in the histogram where we see gaps between observations. Okay, so what I've done here is this is a histogram of the data set that we've been using up to this point. And so you can see our x-axis here, right? This is the features, right? So this is the number of features that have a value of 11 or 12, 15 or 16, 17 or 18, right? 37, 38, and so on. And so what we're going to do is we're just going to visually estimate class breaks based on gaps in this histogram, right? And so to keep with the idea of 5 classes, we're going to look for 5, we're going to try and create 5 classes because we're actually going to generate the class breaks in this part using this histogram. And then we're going to go and we're going to apply them to the, or include them in our Excel file. Okay. So if we want 5 classes, in order to make 5 classes, we need 4 class breaks. Right. And again, the computer has some fairly sophisticated algorithms for determining this. But what we're going to do is we're just going to look and visually try to estimate where the largest gaps are. Okay. So my first idea would be to put one here, right? Because this is a pretty large gap in the data set. So this is going to be at a value of, I'm going to say maybe 83. Right, that's the biggest gap I can see. Right, then I might put another one, maybe say here, at a value of say 44. And then I might look and say, okay, well this looks like a good break here, at a value of maybe say 96. And then I would say another good breakpoint would be here, at a value of say 28, right? And so what we have here is we have our minimum value of our data set, which we remember is 11, and we have the maximum value of our data set, which remember was 100. So this from 11 to 28, this is class 1. Right? From 28 to 44, this is class 2. From 44 to 83, this is class 3. 83 to 96 is class 4. And 96 to 100 is class 5. Right? And so there's no fancy mathematical equation here, at least not that we're going to dig into, because again, computers have sets of algorithms to do this. But visually, all the natural breaks algorithms are trying to do is they're trying to find the places where there's gaps in the data set that make sense to put class breaks in. Okay? So let's go ahead and transfer these values over to our Excel sheet. So we have, for our natural breaks, let's get that out of the way. For natural breaks, which I'm going to call NB for natural breaks, right? We had 11 to 28. If I go back, I'm going to be switching back and forth here just because my memory is not very good. 28 to 44. 44 to 83. 83 to 96. And then 96.1 to 100. Okay, so hopefully that makes sense. Again, natural breaks is conceptually very easy, hopefully very easy to understand. And the sort of integral math behind it is outside of the scope of this class. So hopefully the way that we found these class breaks makes sense. And as always, if you have any questions, please reach out. Thank you.